How's everyone doing? Yeah? Cool. First talk after the keynote. Was anyone at the keynote this morning? Pretty good? Yeah, Douglas, he discovered JSON, so pretty big deal. It's pretty exciting for him to be here. So I'm Dan Lynch, part of the same movement that everyone here also is a part of. Been a part of this conference since the first one, so it's really exciting to see how it's grown a great deal over the last. This is the fourth conference so far, but I think it's just an indication of like the community in general and HTML5, and it's really exciting. To me, it's not just a conference; it's also a movement, and so it's really exciting to see sort of the progression there. So today I'm going to talk about a couple different things. Brief history on HTML5 and sort of how we've come to the point to where we're at right now. How to build large-scale JavaScript application architecture. Something built to last, and specifically how to design a system that's meant to change and evolve, because people and software change, and so how can we build a system that sort of takes that into account? But before all this, so if we go back 25,000 years ago or so, humans, the way we expressed ourselves and transmitted information across different generations was through cave paintings. And if you skip ahead to, actually, sorry here, the printing press, some 25,000 years later, all of a sudden we sort of had this like automated way of being able to share information, sort of democratized, if you will, knowledge, and being able to transmit information much easier across to different people. If you fast forward about 500 years, a project the military was working on called Sage, which was actually just built shortly after the Berlin blockade in 1951, sort of started computer graphics and computer networking. And obviously, we've all heard about the personal computer in the information age. And so the transition here is that sort of like how technology has really affected the way that we can share information. And, you know, HTML5 is more than, I think, just this logo and this conference and this movement. It's actually a way that we're sharing information with each other and sort of leaving our mark on the world. It's, you know, a way, the web is connected billions of people online, so just keep in mind that, you know, there's a deeper underlying purpose to what we're all doing here, and it's really exciting to see everything grow. So, HTML5, it's this living standard, and it's not even 2014 yet. So, you know, having seen how everything's changed over time and how technology's affected the way that we can communicate with one another, and we're all here for this technology, HTML5, which technically the standard isn't even done yet. So we're the early adopters, which is really exciting. Because the web is this sort of like interactive printer, if you will, and we have no idea how it's going to change our lives over the next few years. We have no idea how we're going to be using it over the next few years, because people change, so does software, and in that sense, you know, it's going to be really exciting to see the types of things we can build, how we're going to be building those, and how the web can be used as our medium to convey that kind of information. So I'm going to start talking about the actual architecture and some programming patterns. So a top-down approach to design is sort of, you know, known as modularity, if you will. Definition I found on Wikipedia is that modularity is the degree to which a system's components may be separated or recombined. And a bottom-up approach, conversely, is sort of abstraction, which is taking a process of formulating generalized ideas or concepts by extracting common qualities from specific examples. And I claim that when you combine a top-down and a bottom-up approach, you get large-scale rapid development. And I'm basically here to describe an application architecture that you can use to achieve these goals. And why you would want to do some of these things, well, as I mentioned earlier, people change, so does software, and so you might want your software to evolve with that kind of change. Companies need to manage complexity, so as your companies grow, you're going to add more people to your project, you're going to have more tasks, you're going to need to be able to manage these things in parallel. A lot of time you're going to be adding new code instead of maintaining code. Coworkers depend on your code to make sense. It should be intuitive. Things should appear in the right place. And things should be extensible. So it should be easy to like swap something in or out and have it not break like other pieces and parts, if you will. And if everything's modular, it should be really easy to do testing so that you know, the application itself isn't the testing framework, but sort of each piece of discrete functionality can be tested, if you will. You might have heard of this book called The Mythical Man Month. And it was written by Frederick Brooks Jr., and he says that men and months are interchangeable commodities only when a task can be partitioned among many workers with no communication among them. What that means is that as you add people to your software project, you'll reach a point in time where it actually won't help you get things done faster. It'll actually just increase the number of communication channels among people that are working. It's something like a factorial of like, you know, n minus 1 times n over 2. So it grows very largely rather quickly over time. And the way this translates to code and people is like spaghetti code. So it's really hard to manage, and over time it actually just ends up being sort of like a big mess. So the other end of that is something that's perfectly partitionable. And so if your tasks are perfectly partitionable, then you can add more people to your project, and you actually can get it done faster. And in a perfect world, that's how we would do things. And a way that you can achieve that is using modular development. And so modules, which are these interdependent pieces of functionality, they know little knowledge about the application. And then, in fact, the application then becomes, the definition of the application working is that if the sum of the modules that makes up the application are working, then the application is also working. And so let's get into modules here. So you've probably heard a bunch of different module jargon at the conference, so I'm just going to give a brief definition here. So it's each of a set of standardized parts or independent units that can be used to construct more complex structure. There's various module definitions specifically. So there's like JavaScript module pattern, there's AMD modules and web application modules. I'll actually be talking about all of these. And so JavaScript modules use public and private encapsulation using closures. So here you see that there's a counter variable, and it's being set to this anonymous function that's being evaluated immediately that returns an object with the public interface method increment, which has in its scope this count variable. So in effect, this closure makes count a private variable, and this public method increment, which kind of gives you access to it in the sense that you can receive the incremented value and you can increment that variable. And the next type of module I'll be talking about is AMD modules, just to sort of differentiate here what we're talking about. So AMD is just a way to sort of manage your resources and require things in your application. So here I'm basically just creating a module here. I'm not requiring any. So I'm returning happiness, if you will, and then potentially in some other module I might require happiness. And if you see at the top here, there's this array syntax where I can define the hash name of the modules that I want, and then the function's arguments end up being the value of those modules. So now I have happiness, and I can do something with it and then return some other some other module and use it somewhere else. And I want to point out that there's two different ways you can do this. There's also an NPM style way of requiring. And I actually do want to make a point that I think this is better. Tim Branyan had pointed this out to me last year, and I've kind of adopted it ever since. The reason the array style can get bad over time is it really gets hard to manage. As you can see, I'll put my mouse over to this side. It's really hard to kind of match up the functions to things after you have like 2 or 3 libraries you're using, and so I would just suggest using the NPM style. It's a lot cleaner. So, and then the RJS optimizer will also pick these up. That was like my main concern about sort of embedding require statements inside of a module. But the one thing to note is that you ever have a require statement inside of a function that isn't executed when the application loads, then it actually won't get picked up by the RJS optimizer. So that's an important thing to take note of. And then the last thing is web application modules. So a web application module is essentially just HTML, JavaScript, and CSS. Luckily, we have things like Ember and Backbone and Angular and all these new frameworks that are coming out that let us talk about these types of things in the context of MVC or templates and views and models and collections and things. And I think that that's actually really awesome progress, for HTML5 and us as developers in general. So now we're going to get more into the application framework. So Nicholas Zakis, very well-known sort of JavaScript guru, if you will. A lot of my work is sort of based off of his stuff. I read his books like a long time ago when he was publishing stuff out of Yahoo. Brilliant guy if you ever want to study large-scale JavaScript application architecture. I think he's like one of the originals. So he says that an application framework is like a playground for your code. And I really love this analogy because, as you'll see, you can really build cool things once you get something in place. So at high level, we've got sort of 4 main components of an application architecture. You've got your core. Your core sort of has your base libraries, things like for DOM manipulation, promises, and deferreds, and maybe some async stuff. And the sandbox is sort of the thing that exposes the core to the modules. The modules are sort of where you write all of your functionality, the things that sort of contain all of the HTML, JavaScript, CSS sort of packets or components, if you will. And extensions are sort of like modules, but they actually can modify the core to do things that you might need to use across different modules. And where to start with this, and also to give a little bit of context on where the code I'm talking about comes from. This is the Backbone Boilerplate built by Tim Branyan, another great JavaScript developer to follow, and Backbone Aura, which has now been renamed to Aura, which is built by Adi Osmani, also another large-scale JavaScript application person to pay attention to. So the anatomy of a web module, we've got templates, views, styles, and in the context of the framework, there should be a controller that can load that module into the framework with some lifecycle functions, and I'll get into that. First thing is like how I would store a module. Everyone has like their own sort of approach, but I like to keep things self-contained. So instead of having like a giant styles folder and templates folder and keeping a ton of different things for one module and scattered across different places, it's sort of like a row versus column approach, if you will. So I like to keep my modules very self-contained. So all the styles, templates, and views are all inside of the same folder. And so you might have, I'm using handlebars in this case, some kind of a template and some kind of view here. And I'm just going to point out, so views deal with like event binding. You define which template you're using, and you can add functionality. And here, I'm actually defining a view. And you notice there's a couple different lifecycle functions on this view. That's because I like to use the Backbone Layout Manager. That's also built by Tim Branyan. And you can define your template, you can have a initialize function, which happens whenever you instantiate this object or this view. Before render and after render are really useful for if you need to do some kind of jQuery thing or any parsing of the HTML before it's put into the DOM. And then a cleanup function, obviously, any memory management or any management of any ghost views. The interesting thing is, it used to be that we could kind of not worry about memory with JavaScript. But given the nature of the applications we're building these days, it's actually becoming more important to manage these things. So I'd encourage you to check out the Layout Manager if you're dealing with any MVC stuff, especially Backbone. And for styles, too, I like to encapsulate my styles. I use less. You can use whichever framework you like. But if you just kind of encapsulate all of your CSS in a scoped class name for your module, it'll scope all of your classes. So if you notice, a lot of these things kind of are similar to what web components are going to eventually solve for us. But this is a way that you can do this stuff today. And this will work so that any style that you create for this module will actually be scoped to this module and won't bleed outside. And so the next important thing is the controller. So those are responsible for routing, handling callbacks, and it's sort of like the main JS. If any of you guys kind of came from a computer science background, there's sort of like your application main or your main when you're writing C code. So a controller in the context of the web application module and in the context of what I'm talking about is sort of like that main. It's the thing that loads the module into the application core. It registers the routes and handles all the callbacks, which then will instantiate some view and render it to a layout. And that looks something like this. So it's AMD module. It requires a sandbox, maybe a view. And you notice I have this type controller here. And so the application core knows that this is a controller and then can parse this differently. So you can sort of multiplex, if you will, different types of classes and then just sort of return them as just plain JavaScript objects and instantiate them at runtime. So every module has access to the sandbox. And what that does is it's actually what's known as the facade pattern. So the facade pattern sort of exposes something else, which means you actually never touch the core as a module. So you probably want to keep your sandbox the same. It's sort of like an agreement or a contract, if you will. So you can always swap out your core. You can always swap out a module, but you probably don't want to swap out your sandbox. Because that's something that all of your modules are touching. So if you have to do some giant refactor and change your sandbox, you're probably going to run into a lot of trouble. But if you ever want to just change a module or change your core, you'll be perfectly fine. And so the way that you usually implement that is that you have some file that literally is just functions that are calling functions on your core. So that way no one can actually you can't ever touch the core. It's sort of just exposing it through a proxy, if you will. And I'm using the apply here and passing in all the arguments. So it's a pretty simple interface. And here's an example of why you'd want to do this. So instead of using jQuery get, for example, and just querying for data in your application, you might want to use sandbox request. And then request might use jQuery get. It might use something else. It might cache the values. It might throttle your requests. But if you had written jQuery get all over your application and you wanted to do some sort of throttling, I mean, you could probably proxy the jQuery get function, but this is a much cleaner way to do it. And it sort of buys functionality for you by having that layer of indirection. So the application core is responsible for the lifecycle and the intermediary communication between all the modules. So there'll be this is a very sort of high-level abstract way of talking about application core. There's a ton of different large-scale JavaScript application frameworks out there. But the one thing, this is sort of like the take-home that I want you guys to have of how you could build it yourself or what you should look for. So there's a way to register modules and a place to store references to the modules. There's a way to start and stop, sort of handle the life cycle of the different modules. And then there's some sort of pub sub type functionality to create for the intermediary communication. You might see on or emit instead of publish and subscribe. It's really doesn't matter. And so the way that the facade is implemented from the core, for example, here's the core. So I have a subscribe and unsubscribe function, and I just return the core. And then the facade would actually just require the core. I create a new object, and I do sort of the proxy methods where I just return functions that then just call the core functions. And you can do other things here too. And then the way that a module uses the sandbox, which is sort of the facade pattern to expose the core, is you just require the sandbox and you call functionality. So maybe the sandbox has a way of creating views, the sandbox has a way of creating modules, the sandbox has a way of publishing messages, all these different sorts of functionalities. So, the big point of the communication hub is that if you go back to that Mythical Man Month graph in your mind, there was some point at which you add more complexity. You sort of have this factorial increasing number of communication channels. And so the mediator pattern gives us this sort of flat constant. As you add more complexity, more functionality, or more people to a problem, you actually only have a constant number of communication channels. And one very particular way of thinking about that, like if you ever wrote libraries that require each other, you always run into a dependency problem where maybe your system won't compile, or an RJS optimizer might freak out. And so the mediator pattern is really big on solving those issues. And so you want to build everything for extension, and then the way that sort of works in this framework here is that the extension can actually modify the core, and then you just expose those methods through the facade pattern to the sandbox. And specifically what I want to talk about is a lot of the frameworks I've found, they really don't abstract a lot of the really important things I think they should be. Because if we're building frameworks for web applications, it seems that there's like these core components of web applications that we're constantly repeating ourselves like over and over and over. Because in my opinion, like every web app should have routing, some sort of data, and some sort of way of rendering layouts. And so if you don't have those things, you're sort of rebuilding and reinventing the wheel every single time. And so I think you should not only decouple your application, but you should also make some abstractions to some of these core things here. And I'm going to talk about how to build some of these specific extensions. So the top-down approach, just to bring it back to the main point, the modular development side of things is using modules, extensions, plugins, and components for things. And then the bottom-up approach, which is abstraction, is that we're going to make extensions for routing, creating pages and layouts, data, and also APIs and things like that. So sort of combining the two to have a large-scale, rapid development environment. So decoupling your routing and your rendering, the way that I like to do it is have the modules themselves, the controllers, register their routes with the application core. The reason you want to do that is sort of like having a sub-router inside of each module. And the route events are actually passed as messages. So you're not actually using like some backbone sub-router plugin. You're actually just managing messages that are being passed to the modules on the route event. And then the layouts are also rendered via messaging so that no module ever has a reference to the layout, and the layout actually doesn't have a reference to any other view. They're sort of just messages that are passed across the application. Okay. So there's a very special function that you call in the very beginning of the application when it's loaded, and that's the boot function. Sort of boots the application, if you will. And what you're going to want to do is you want to like initialize any data. So I like to use sort of a declarative approach to finding data, where I'm maybe using a JSON, and that will actually create models and collections for me. using metaprogramming. And so I'll load my data, I'll load my extensions, I'll start the layout, and then I start the modules in the router. And the reason I do that is because there's a few race conditions in that the modules need to register themselves with the application core before the router can actually be started and know what all of its routes and callbacks are. And we'll get into some of these details as well. And then you'll actually want to register all of these in the beginning. So this is the if you ever looked in a require.js configuration file, there's like a deps property which points to a sort of main file. So this is sort of like the main, and it requires the core and sort of registers, if you will, like the router, the data, and the layout, so that you can actually, in the original code I was showing you, be able to start those things. And these are actually just asynchronous functions. I'm using the async.js library to separate these. It's sort of that way, like, for example, the layout won't actually go to start the modules until it's in the DOM. So you're going to start your extensions, the layout's going to put itself in the DOM, the modules will start, and then the routing will be enabled. And that's actually a really important point. If you don't have anything in the DOM, you can't really do much. So the module code here it's pretty simple, but on the start function, you notice it's going to subscribe to a route, and I'm specifying some dependencies here, and then there's a render function which will actually publish a render message with a view that's been instantiated. And it's also, if you're wondering what this deps thing is, I like to do proxying on the render function for my controllers so that it'll actually grab those dependencies and wrap that function and pass in the arguments that contain that API endpoint based on the route parameters. But in essence, you can see here that whenever this module sort of gets instantiated by the core, the first thing that gets called is the start function, and all it does is then subscribe to a message. And then when that message reaches this module, it basically calls the render function, which then passes that message to the layout. And then the layout then actually subscribes to the render message. And then the cool part is here that you can completely now abstract like how you're dealing with any navigation paradigms, how you're doing any animations or transitions between your views. Often people really kind of couple these things together, and it's really hard to maybe change the way, maybe you want a flipboard layout one day, maybe you want sort of a Pinterest style layout, and this sort of decoupling using message passing will really help you to achieve that agility. And so what that looks like in the end is it's sort of this like, the router sends a message, it triggers a message to the module then passes the view to the mediator, which then sends that to the layout. So the module and the layout and the router, none of them actually even know about each other. They're sort of just like using this contractual agreement of which messages to use. Okay, cool. So as I mentioned earlier, a group of modules or a set of modules can represent an application. So if you can manage module groups, then theoretically you could have multiple applications running inside of a single page app. And so another important extension that I think should be a part of your application core, application framework should be the ability to manage these groups. And I'm going to talk about how you would modify the system to do this stuff. So the first thing you're going to want to change is the code that boots the application. The one we have right now just sort of loads the router, data layouts, and extensions. But what you really want to do is have this notion of actually registering groups of modules, and then you can boot the application into a specific group. And so this sort of allows you to kind of, maybe have different layouts associated with different groups. So maybe you have a dashboard, maybe you have analytics, maybe you have different portals of your website. You're not going to want to like code those all in some giant collection together. You probably want to be able to modularize those groups of modules. And the module group extension is a really good way to do that. The other thing you're going to want to do too is change the the boot function and then make a way to change groups. And so all you're really doing instead of starting modules is passing in the group into the booting functions. And so what ends up happening is you sort of inject this layer of middleware on the front end in front of every single route call. So instead of just route callback, you sort of route, you check, is this in the current group? If not, you change the group, and then you load that part of the application, and then you can call that callback. And if you are in that group, you just call that callback. So let's say someone's in like a admin section of the website, and then they log out. If the route logout is not in the admin section, it will actually start whatever group that route lives in and load those modules, and then go to that callback. And so that actually brings me to the next point, which is sort of like protecting resources or adding sort of a middleware on the front end. So if you look at typical backends, we have this really easy way of adding middleware to our applications. So you have a route, it hits some middleware, and then you can go to the controller. And typically, I'm seeing a lot of this in front-end development where we just have a route and then a callback. So there's really there's no way to have sort of this notion of middleware on the front end. And so, what if we had something like this where you could do a route, you could have some arbitrary state machine, and then have some callback if that fails, or have a way to call the original controller's callback. And so there's a way that you can do this. What I did, ignore the slide for a second, is just you can proxy the backbone history navigate function. There's also a library called route filter. So that's how you can actually achieve this. Specifically with the slide, you'll have to change a couple things so that each time you change groups, you're going to have to check and exit the group, and then you're also going to have to enter the group. So if you're familiar with state machines, you sort of have this like function that you call whenever you enter a certain state, and then when you transition between states, there's also some function. And so you can actually end up defining these things as promises and then loading those into the application core. And so that in the end, you have a system that's a little bit more complicated. But if you have this system, it's super generalizable to where you can have different module groups. You can have different logic that allows you to navigate between those module groups. And the way that they're all connected is through routing. So, basically, if you pass through the state machine, you check the group, and you may have to swap the layout and start those modules, call the enter function from the state machine, and then you reset the router and you can call the callback. Otherwise, if you pass the state machine, you're already in that group, you can just call the callback. And if you don't pass whatever business logic is in the state machine, you can actually just call the fail function. That might just log somebody out or send them to another route. And obviously, this is all on the front end, so it's not really protecting resources, if you will. But it's a good start, and it's also a good way to manage your application. So if you need to create a new dashboard or something, you can just make it a new module group. You can create 10 or 20 modules that are all associated with that group, and they won't be loaded into memory unless that set of routes has been activated. So just to kind of sum it all up, this is sort of the picture that you should really remember. You have these modules. They have this sort of intermediary communication through the sandbox to the application core, which really is responsible for managing the life cycle of these modules. You can do really interesting things by defining different types on the modules, the main JS functions that get read into the application core. So for example, when I had type controller, the application knows that that's of type controller. It can read the certain properties on the object that's returned by the module and then generate a controller object. You might want to make a layout object. You might make a plugin object. You could actually just arbitrarily make new objects in multiplex functionality based on that type parameter. And so you can sort of extend your own application components. And then with extensions, you can do really interesting things that sort of cross-cut your application through the sandbox. For example, one of the things we've done is we've been paying a lot of attention to different libraries out there. and the different pros and cons of Backbone and Angular and stuff like that. So we've written some pretty interesting extensions to augment Backbone to have some of Angular's functionality. So we have this notion of functionality injection, or view mix-ins, if you will. We've also built some things that give us directives in Backbone, so that we don't have to have this whole like Angular versus Backbone debate. Well, we just kind of build them as extensions into our platform. But just remember, sort of, make things very extensible so that you can reuse it. And sorry here. Let's see here. So the extensions I would actually just build from like day one. If you have the time to build a application framework, I would just like literally the whole bottom up part is like you can actually hard code this. You don't. It doesn't have to be some uber generalizable thing. Like your application's gonna have routing, it's gonna have layouts, and the state machine could be optional. But I think it's a really good addition to have business logic being able to sort of inject itself between your routing in middleware, and sort of having a way to manage your different module groups. So that's the bottom up plus top down, is that you can abstract these things away by sort of building them into your application so that they're there. You kind of brush those details under the rug. You just have them, you abstract that away so you can just reuse it. And I mentioned some of these things. Okay, so we covered how to do this bottom up, top down approach to development. To take these like core applications, core components of a web application, like routes, navigation, layouts, and sort of port them into this modular framework, if you will, which some people haven't really completely solved, and there could be other ways to do it as well. And I want to go over a couple tools that were used to describe in the description of the framework I've been talking about, and also some of these were used also in this slide presentation. So Backbone Aura is built by Adi Osmani. It's really good to decouple your code. It also deals with module lifecycle. There's the Backbone Boilerplate. This adds structure to your Backbone application. A big problem people have is sort of managing like large amounts of files and folders that have to do with modular, just JavaScript development on the front end. Handlebars is a really great way of handling your templates. And for your build system, I'm sure a lot of you guys are already using Grunt to automate repetitive tasks. Bower is a really cool front-end package manager. It also kind of, if you just build a couple Bower modules and then require them in other Bower modules, it kind of just like automatically puts you in the mindset of building things in a very, building small components kind of mindset. And require.js, obviously managing dependencies using the RJS optimizer to minimize the amount of HTTP requests is also really important. And another thing, the future, Node.js, I would really encourage you guys to check this out. The community is really growing. You can do a lot of interesting things with code sharing on the front and back end. The amount of modules that is just growing, and it's pretty amazing. Some people I want to give some credit to: Nicholas Zakis, Adi Osmani, and Tim Branyan. Really great front-end JavaScript pioneers. I also built this entire presentation in this framework, LaTeX to HTML5. So this whole presentation was actually HTML5, but I wrote the entire presentation inside of LaTeX, inside of these script tags. So it's sort of just an interesting way of dealing with it, and I could kind of demo it. So you can, just one layer of abstraction that was kind of fun to deal with, and that's also, if any of you guys are into academics, this is a platform you can use to really make things very extensible. So I actually wrote the slide presentation as extensions on that platform to sort of eat my own dog food, if you will. So thank you very much. I'll have 10 minutes or so for questions.
So this is great. When you're building your modules to live within the bigger application, what is the approach that you take? What are the tools that you take for your team members to follow certain guidelines? Or are there any guidelines that you, is it mostly about documentation, or are there any code tools that you use for simplifying the process?
Yeah, so similar to Ruby on Rails has like these sort of command line utilities. You can do that combined with things like Component and Bower to sort of automate that process. So I would say it's a combination of documentation and maybe a couple command line utilities.
And when your module is being built, how do you abstract out the API calls, or how do you provide them so that each module can be tested individually? Built-in tested individually.
Built-in testing for API data as well?
Yes.
Okay. There's an NPM module I've been using for that called Faker, which I sort of describe my schema. It looks at the type of it, and then I have a hash which maps to a function in Faker, and then it generates fake data based on these API endpoints. And I actually have to run a server to serve up that data, but then the front end can then query that and sort of automate the generation of fake data based on a schema that you described.
Thank you very much.
Cool.
Can you talk about your recommendations for large JavaScript applications that are delivered on the web, but I want to load my code like little by little, but still in an optimized and maybe even consolidated way? Like, does Require.js solve that? I know they solve it where like they can consolidate and optimize all of the dependencies in one go. What if I want like, you know, a handful of dependencies and those can change?
Okay, so what I would do, I would package the application core in the RJS optimizer and then sort of bundle certain module groups that aren't actually inside of the minified files and have those packaged with different sort of hashes, if you will, so that you can kind of keep updating them. But then you update the module groups as packages that get pulled down asynchronously as another HTTP request. And then, go ahead.
So is the process that you're describing something that we do as developers offline at a build step, or that happens automatically
I think
at the time of the request?
Yeah, you could automate it using the module groups as a first sort of basic step, but I would assume you'd probably want to do some sort of analytics on which modules people are using the most.
Okay.
And then sort of group bundles based on usage, if that makes sense.
Right.
There's also something that Facebook came out with for managing this problem, which was called Celerity. And it sort of manages like breaking up your application into smaller pieces that are cacheable, and you can invalidate the cache just based on the hash values of the file names.
Okay, cool, thank you.
Actually, I had a question about the Angular app project.
Okay.
A lot of the structure that you were going over seems to mirror that. So would you recommend that as a starting place?
What I said was that we had done some stuff to augment Backbone to do Angular-like things.
Okay. So you guys don't deal with Angular specifically?
No, I think Angular does some of the stuff I was talking about. So if in the context of what I mentioned, most of it was using Backbone, but I'm totally sure there's a way to apply all this information to Angular. Maybe shoot me an email. I can think of something and do some research and find out for you.
Okay. Thank you.
Cool.
How do you spell celerity?
I think it's CEL celerity. I don't know. I have to type it. CELERITY.
Cool.
It was really hard for me to Google it. I remember that. Just, it's like package management, Facebook, Celerity, and then like look around for like a page or two on Google. It was really deep in there.
Are there any other package management libraries that you would recommend?
You know, other than require, Bower, NPM.
Well,
you know.
in terms of being able to load modules from the client once the core, you know, has been pushed down.
Yeah, I mean, I think Require's really done the best job at that. What I would probably end up doing is you might want to, it's probably something that people, we might need to build something to do that. I don't know if there's anything that actually exists right now.
Yeah, as I understand it, Require brings everything down in one go, right?
Yeah, well,
Yeah.
if you use the RGS optimizer and you have, when you do the minification process, it generates a file that has all of your modules inside of it. If they're not inside of that hash, it will then get them from the internet. So what you could do is just, you know, store which modules are most core or extensions in the RGS optimized version. There's a way to specify that in your configuration file for the RGS optimizer. And like I'm using Grunt, for example. There's a way to exclude certain files from the optimizer, and then those will just be pulled down from the internet. But I think the magic would happen in determining which modules you're pulling down and how to group some of the modules as other concatenated RGS optimized sort of bundles, if you will, and pulling those down. I think that would actually be an interesting project.
Thanks.
Any other questions? I'll be putting it on the HTML5 developer website. Since I built it in HTML, there's a little bit of rejiggering I'm going to have to do to get it to be on sort of a PDF type interface. But I'll make sure that happens. Yeah, it's actually not that big. I'm not totally a numbers guy, although I used to study a lot of math. But it's very minimal. I mean, it's. I would just check out Backbone Aura. There's also, I forget the name of the other one, but you know, it's no big deal. Yeah, I mean, it's like using Require, right? It's like you wrap things with a little bit. So the facade, you just do a little bit of a proxy. Theoretically, you could get rid of the facade if you're not trying to do something really large scale, and you could rip out the facade and just go right to the core. I don't know how much that would actually buy you, though, especially without that layer of indirection. It really kind of saves you in a lot of different ways.
How do you handle like versioning of modules that might be implemented across lots of different applications on the large scale site? I'm sorry, that was part of it.
Oh yeah. Well, I think one way of solving that right out of the box is just to use something like Bower. You can specify in your Bower JSON or component JSON which version of particular file package you're using. If you're using them as separate GitHub repos. But if you're doing something like homegrown and you're not using Bower, I typically just then have to rebundle everything and ship it out. So it kind of zips everything up. I give it a new hash name, you know, based on the version number, and then it kind of invalidates the cache for the client. Yeah.
We actually building in app in Angular, but we have use cases where we have.
Oh yeah. Okay. We have 1 minute and 26 seconds left.
So the question is that we're building an app in Angular, but we are kind of like the core platform, and we have extensions or other smaller apps that needs to live inside our UI, and we want to give them the flexibility to write in any other framework that they might have already picked, like Backbone or EXEJS or whatever.
Oh,
so I wanted to hear any thoughts that you might have on that.
Yeah, there's something called the interface pattern that you could use to define an interface for an extension, and then you could write that interface for each framework. So if they wanted to use Backbone and you wanted to do what was maybe done as a directive in Angular, you could do it as a layout or view mix-in in Backbone, and then what you could do is define an interface. So I would just look up the interface pattern. It's a programming pattern that you know, I'm not sure if it comes from Java where they had the abstract classes and you sort of define what methods you have to have on this particular
Sure.
piece of functionality, but then if you implement it in that way, it should work.
Okay, so basically you just define an interface for every piece of functionality that you
Yeah,
kind
I
of
mean,
want.
I would subclass a function that looks for methods that have to be implemented or it throws an error. And potentially there's some sort of documentation that describes what those methods should do. So I have 4 seconds left. Thank you very much. Go HTML5.